Here's your lecture for Pre-Calc 11.1.2. It's how can I graph the polar functions? So you've probably seen this on your calculator. The modes on a calculator, there's polar graphing mode. In today's lesson, you will explore this feature and generate a variety of interesting graphs that use polar equations. Graphing a polar curve. Polar functions are functions with variables r and theta, usually written in r equals form. To graph a polar function, use the same steps as when you first learned to graph using Cartesian coordinates. Make a table of values, plot the points that correspond to the values, and sketch the graph. So what we're going to be doing is graphing r sine theta in polar form. Okay, so we're just going to complete the table. These are like our ordered pairs, but they're going to be in polar form. And then we're going to plot the points and see what the graph looks like. So the way that you can fill this out, this table, is just, if you remember, r is the length of the radius. It's like the magnitude. If you're talking vectors, it'd be the magnitude of the vector. If you're drawing triangles, it would be the hypotenuse of the triangle. And theta is your direction. So theta is like your angle measure that you're opening from the positive x-axis. So you can just go on your unit circle and fill this thing out. Like, we're going r equals sine theta. So what's sine of pi over 3? So just go pi over 3. It's root 3 over 2. And I know that if I put that in my calculator, root 3 over 2, that's about 0.86. And similarly, root 2 over 2 is about 0.7, and a half is about 0.5. And you'll notice we're going to keep getting those same values all around. Like, the values repeat around the unit circle. So I went ahead and filled out this graph. This is the same thing as we have here. Okay, so when I plug in 0, the sine of 0 is 0. The sine of pi over 6, let me see if I can make this better. The sine of pi over 6 is a half. The sine of pi over 4 is root 2 over 2. I started writing them as decimals, though, because root 2 over 2 is about 0.7, and that makes more sense with my graphing. So I just went all around the whole unit circle, and I just got these, I just, followed whatever angle measure, and I'm grabbing the sine. Like sine of 5 pi over 4 would be negative root 2 over 2, which is actually negative 0.7-ish. So then I'm just going to plot the ordered pairs. So a radius of 0 and a direction of 0 would just be right here. And then a radius of a half, there was actually a typo in this sheet, and an angle of pi over 6. This is that special paper. It just opens the angle up at pi over 6. A half, well, I decided to organize my work on this by counting these circles. I know that the highest number I'm going to get is 1 or negative 1. So I wanted this outer circle to be 1 or negative 1. And so I see all these circles I can count by. I can go 0.2, 0.4, 0.6, 0.8, and then that would be 1. So I'm just kind of estimating on here, like 0.5 would be like this. 0.2, 0.4, well, there's 0.6, there's 0.4 and 0.6, so I put 0.5 right there. And the reason it's on this line is because it was pi over 6. Pi over 4 gives me root 2 over 2, which is about 0.7. This is the pi over 4 angle. I need 0.7-ish, so I'm going to go 0.2, 0.4, 0.6, that's 0.8, so 0.7 I put right there. So yeah, this thing it takes a long time. It was kind of a little bit of a hassle. Pi over 3, well, pi over 3, I got root 3 over 2. Root 3 over 2 is about 0.86, which is close to 0.9. So I went 0.2, 0.4, 0.6, 0.8. well, I just put it right there, you know, somewhere between 0.8 and 1. Okay, and then we're right here now. Pi over 2 with a radius of 1. Well, there's pi over 2. So you can see that if I were to connect my dots, they're kind of going around like this. And so I'm only right here. I've only done these ones. 2 pi over 3 is this angle, and it's 0.8-ish, so I put it there, 0.86. 3 pi over 4, that's this one. 5 pi over 6, that's this one. And then pi is 0 again. So if I were a better grapher, this would look exactly like a circle. It kind of does look like a circle. So it's interesting. But I haven't even done the rest of these values. So what's going to happen here, I'm going to have negative radii. So 7 pi over 6, let's remember where 7 pi over, there's 7 pi over 6, and I want the sign, so that's negative 0.5. And then 5 pi over 4, well, that's negative, root 2 over 2 is about 0.7. So notice it has a nice symmetry to it. So if you go through here, you can just, all these values just came right off my unit circle, but I put them in decimals because it's easier, makes it easier for me to count where I'm going to put my dots. So there we are. So at 7 pi over 6, which is this angle, I have to go a radius of negative 0.5. So I'm on this angle, and so I have to follow it across the origin to negative 0.5. So, well, that just lands back on that dot that I already had right there. That's 0.5. So when you have a negative radius, it makes you have to, I guess it's reflecting about the origin. It makes you reflect it to the other side of the origin. So 5 pi over 4, that's this angle right here. So I have to reflect 0.7. So that's 0.2, 0.4, 0.6. Well, I already have a dot there. Huh. Seems like I'm going to have dots everywhere. I already have dots, right? There's probably a dot for this one. 4 pi over 3. 4 pi over 3 is this angle right here. 4 pi over 3 is negative 0.86. Well, 0.2, 0.4, 0.6, 0.8. Hey, so I'm going to stop. I realize now that all of these points, when I plot them, they're going to land on top of the points that I already put. So I guess the moral of the story is that when you see r equals sine theta, it looks like a circle. And it's not centered at the origin, but it has a point at the origin. And it has a point at, in this case, it's 0, 1, right? What do you think would happen with 3 cosine theta? Oh, cosine. Well, that's very interesting. So I don't want to go through this long. I don't think there's time for me to go through plotting all these points. But I could do this in a similar manner. I would just go, okay, so I need 0. What's cosine of 0? Let's find cosine of 0. Cosine of 0 is 1. So I'd have 1 times 3. Well, that's 3. So there's going to be 0. Oh. So let's now, I was calling these 0.2, 0.4, 0.6, 0.8. I'm thinking, well, let's get some ordered pairs before I decide. I'm thinking I might just want to count by ones here, and I'd have 1, 2, 3, not sure. What about pi over 6? What's cosine of pi over 6? So cosine of pi over 6 is root 3 over 2, which is about 0.8, but then I have to multiply it by 3, right? Because we're doing 3. So let's see. going to be about 2.59. And if you get the idea, we're just going to go and do that to all of these, and then we're going to graph it on here. Now I'm going to fast forward and show you what the graphs would have looked like, okay? Because there's just not enough time to do them. You can do them on your own. So for So for 3 cosine theta, I would have ended up with a circle, but it's kind of going off to the side, and its radius, well, it has a point at 0, 0, and a point at 3, 0. Okay? And so all of these, they're wanting you to just do these by plotting points, but later on we're just going to use a graphing calculator. You just want to notice that cosine always is a circle, and it always goes off to the side, and sine always goes up. But this one, negative 2 sine theta, look, it's facing down. It's down here because it got reflected across the origin. So I'll start part 2 with 11-15, but let's read this. If the equation is r equals k times sine theta, then the graph is a circle through the origin centered on the y-axis. So sine is centered on the y-axis. Okay, and that makes sense because sine is our y value. If the equation is r equals k times cosine theta, then the graph is a circle through the origin centered on the x-axis. K is the diameter of the circle. If k is greater than 0, then the circle is on the positive portion of the axis, and if k is less than 0, then the circle is on the negative portion of the axis. Okay, so I'm going to start a part 2 of this, and we'll do 11-15.